Hello my dear students, welcome back, and today I want to discuss the alkanes. Particularly I am going to discuss here preparations. Preparations of alkanes by various methods we are going to discuss. In that the first method is from alkyl halides. Now this reaction is very simplified. Now listen what happens. Now I take a generalized reaction, that is R is alkyl group and there is halide group X. Now this molecule, that is alkyl halide, is reacting with the reductant, and we get the product, that is RH, and along with that the byproduct is HX we get. Now thing is that what are the reductant? The reductants are the molecules which provide the hydrogen. Okay, so we can take some examples for the reductant, that is zinc is coupled with the copper used in presence of C2H5OH. This is a reductant. Or else you can use aluminium mercury couple. Aluminium is coupled with the mercury in presence of C2H5OH in presence of ethanol. Or you can use sodium metal in presence of ethanol, that is C2H5OH. Or else you can use some more, the direct reducing process, that is platinum you can use, palladium you can use, nickel you can use at around presence of hydrogen at around temperature of 300 degrees Celsius. The platinum and palladium you can use at a lower temperature, but nickel when you are using, the temperature should be 300 degrees Celsius. And along with this you can use one more reductant, that is zinc in presence of HCl, or directly you can use here lithium aluminum hydride. Okay, this is very important reagent or reductant. Okay, let's have one particular example here, that is, let me have here CH3I, methyl iodide I am having here, methyl iodide, and that is reacting with the first reductant, that is zinc copper in presence of C2H5OH, and we get the product, that is CH4 plus HI. So this is what we get the product here. Now the second method we're going to discuss. The second method is, so let me have some other color here. Second method. The second method is from carboxylic acids. From carboxylic acids. Now what I will do, that I will take carboxylic acid first, that is RCOOH, and now this carboxylic acid is allowed to react with the sodium hydroxide, and acid base reaction is there. Obviously we get here salt, that is RCOONA, and we get here the molecule of water, that is H2. Now we need this sodium salt of carboxylic acid, that we can use in the next process, that is known as the decarboxylation process. The first method, that is decarboxylation method. Decarboxylation method. This is quite very important method. So in this we remove the carbon dioxide, or one carbon is removed, so therefore it is called a decarboxylation, or COOH group is removed. Now I will take here this molecule, that is RCOONA, that is R C O Na. The name we're going to write here, sodium carboxylate, okay. So now we'll react this with a sodium hydroxide, NaOH, in presence of calcium oxide, and we get here on heating that RH we get, and along with that there is liberation of sodium carbonate. Later when it is heated, it decomposes into carbon dioxide. Now this sodium hydroxide and calcium oxide together we can call as a sodium or soda lime. It is called as soda lime. Now whatever the product we get, that is alkane. And what are the number of carbon atoms are there in the alkanes? If you are using the n number of carbons in a sodium carboxylate, in alkane there is n minus 1 number of carbons are present. Okay, we'll take one particular example to understand this reaction. I will take here sodium salt of acetic acid, so that is CH3 COONA, and that is allowed to react with sodium hydroxide NaOH in presence of calcium oxide CaO. Even you can write in the bracket also, you can put a bracket like this. Okay, no issues with that. Calcium oxide, and the product is CH4 will be the product, and along with that you will get Na2CO3 is produced, right? Since the COOH group, so where in the starting point COOH, here it is somewhere, it is there, yeah, here is COOH group in an original acid is removed in this process in the form of carbonate. Hence the reaction is called as a decarboxylation reaction. This is called as a decarboxylation reaction. Now there is another method is there. This is a second method. It is also kind of a decarboxylation process only. The process is done by electrolysis. The name is Kolb's or Kolbe's electrolysis synthesis. Now what I will do, that I will take the same molecule, that is sodium carboxylate, that is general formula I will write RCOONA, general formula, that is sodium carboxylate, and you have to mix with water, that is H2O, 2 molecules of H2O, 2 molecules of sodium carboxylate, and electrolyze it. Electrolysis. After the electrolysis, it convert into R plus 2 molecules of carbon dioxide is produced, plus there is liberation of hydrogen gas, and then we get here 2 molecules of sodium hydroxide NaOH. Now in this particular process, what we can have, we can write here the mechanism. This is quite important mechanism we need. So to understand this total reaction, first we'll take the 2 molecules of general reaction. I will take CH3 COO minus. It is ion, which you can say that you know that the sodium carboxylate is a salt, and when you dissolve in a water, it is in the form of anion and cations. So anion, which is having excess of electrons, after the electrolysis, so it becomes here CH3 COO, free radical is generated. Along with that, it gives 2 electrons. 2 electrons are produced, and this entire process is happening at the anode electrode. Oxidation is taking place here. Oxidation. Okay, so now in the next step, we'll write here CH3 COO free radical, two free radicals I will take. So in this process we'll get two methyl free radicals, CH3 free radical, plus along with that we get two molecules of carbon dioxide are liberated. Now in the next step, two methyl free radical, that is CH3 dot plus CH3 dot, share their electrons. They share the electrons. The one electron is shared, that we can show here with a single arrowhead. So then it forming here CH3 bond CH3 is formed. So this entire reaction is taking place at the anode electrode. Now what is happening at the cathode electrode, that we can learn here at the cathode electrode. So at a cathode electrode, reduction should be takes place, and we know that in a reaction mixture there is a Na plus ions are there. There is two molecules, two Na plus ions are there, and these ions consumes two electrons and converted into two sodium metals. And this reaction is occurring at the cathode electrode. Okay, and in this case reduction is taking place. Reduction process is going on here. Now this sodium metal is very reactive, and that will definitely react with the water molecule, that is H2O, and forming here hydrogen gas and the two molecules of sodium hydroxide. So this entire reaction is taking place at the reduction, or you can say that cathode electrode. So this is all about the Kolb's reaction, and next we're going to discuss that is a third process, third reaction, that is Wood's reaction. Wood's reaction. Now in the Wood's reaction we have to take alkyl halide again, that is R, Br, sodium metal, and again Br, R. So two Br are there, we need two sodium metals. Now these reaction mixtures are taken in a dry ether. So what happens here? Now this is the combination takes place. The bromide get combined with the sodium, and we get here R plus sodium bromide is formed, NaBr. Two molecules of NaBr is formed. Okay. Now we can write the mechanism for the Wood's reaction. The mechanism may be two types. The one mechanism is, you can say that, ionic reaction mechanism. The second one is the free radical mechanism. We'll see the first one, that is the ionic mechanism. Ionic reaction. In the ionic reactions, I will take one particular example, that is C2H5 Br, and there is a sodium metal. Now these two together reacting and forming here C2H5 minus and Na plus, the salt is formed here, and along with that we get here NaBr. Now the thing is that, what is the name of this compound? It is called as ethyl sodium. This is called ethyl sodium. Ethyl sodium, and sometimes it is called as a organometallic compound. Organometallic compounds. Okay. Now this is the first way where we can get here organometallic compound. In the next step, we can use here C2H5 minus and Na plus. Now it is a salt, it is easily soluble in water, and now we can get here C2H5, the Br is there here. Now this negative charge will interact with this carbon containing Br atom, and Br atom get eliminated out, and by that we can get here C2H5 bond CH2 then CH3 we get. And along with that, there is a formation of sodium bromide takes place, NaBr. Now in this case, the 1, 2, 3, 4 carbon are there, they are connected in a chain, therefore it is called as N-butane. N-butane is formed. Now come to the next, that is a free radical reaction. We can see the next one, the free radical reaction. Free radical reaction. So in this free radical reaction, we will take C2H5 Br, and in presence of sodium metal, it going to form a free radical, that is CH3. I will write in the explained form, CH3, CH2, and here will be the free electron, and then the Br. So usually what happens, there is a carbon and Br bond is there, no, in that homolytical bond cleavage is taking place. So therefore one electron I have to write on the carbon, the other one should be with the Br, and that will combine with the sodium, and it forming here NaBr is formed. Now this free radical, there are two free radicals are possible. We can write here C2H5 a free radical plus C2H5 a free radical, and we get finally that is a C4H10 we can take, and this is N-butane now, N-butane. So this is a free radical mechanism, and one thing, that is whatever the combination is, this particular step is called as a dimerization method. Okay, hope you understood this. Now we move to the next one more reaction, one particular reaction we can study here, that is from Grignard reagent. This is a fourth reaction from Grignard reagent. Grignard reagent. Okay, we all know that a Grignard reagent we can write here RMgX. So R can be generated here as a R minus. So R minus need here a hydrogen to combine with the hydrogen and form here alkane. So therefore it will going to form here RH, and along with that we get here Mg. In the bracket I will write Z, complete the bracket, then I will write X. Then what is this ZX? H it is, ZH. This Z is called as a compound containing active hydrogen. Compound containing active hydrogen. What is the meaning of active hydrogen, students? So this is quite interesting, that any compound which donate the H ions, H atoms, they are called as a active hydrogens. For example, H2O is an active hydrogen. Okay, we'll take some more examples. NH3 is also an containing active hydrogen. NH3, R, C triple bond CH, or acidic you can say that, C6H5OH. And then we can write here acetic acid, that is CH3 COOH. Next we can write RNH2 or R2NH, or we can write here pyrrole, or lastly C2H5OH. Any H plus giving substances or compounds are called as a active hydrogen containing compounds. Okay, this is all about the four methods we discussed here. In the second part also I am going to discuss the same thing. Let's see. Next method from Frankland, that is next reaction. This is the fifth reaction we are going to discuss. Frankland reaction. Okay, we'll see that what is there in the Frankland reaction. The Frankland reaction is same like a Woods reaction. In the Woods reactions, we have taken alkyl halide, and here also we will take alkyl halide, but here it is restricted, that is alkyl iodides are taken. Instead of sodium metal in a Woods reaction, we have to take here zinc metal. The same type of reaction is taking place here. So now this is the combination takes place here. Now we can get here R, bond R, and along with that Z2 molecules of ZnI2 is produced. Okay, not two molecules, only one molecule is produced. So that is ZnI2 is produced. Okay, so this is a Franklin reaction, and in that alkane is produced. Alkane is formed here. Now in the next step, Sabatier reaction. Next reaction, that is Sabatier reaction. This is a sixth reaction. Sabatier Senderns reaction. Okay, so this is very simplified reaction, students. This is nothing but a reduction of any of the olefins, or you can say that double bonded or triple bonded alkanes, alkynes to a alkanes using hydrogen in presence of nickel catalyst at 300 degrees Celsius. So I will take a generalized reactions are CH double bond CH single bond R. Now this is an olefin, and to this you have to add hydrogen gas. So that can be happen only in presence of nickel at 300 degrees Celsius. A product is this hydrogen is get added here. So therefore I don't want to show the arrow mark here. So directly I will write here R CH2 I am going to write, then single bond CH2, then R. So same way I can write here R CH. Okay, I don't want to write here CH. We'll take one more example, another example, triple bonded compound will take, then R. So plus hydrogen gas. So particularly two hydrogen molecules are needed. So again the same condition, nickel at 300 degrees Celsius, and we can get here R CH2 single bond CH2, then we can get here R. So in all the cases we get here alkanes. So this is nothing but a reduction process. It is reduction. Okay, so when the catalyst, particularly when you are using a platinum catalyst or palladium catalyst, you can use them in a room temperature, RT. You can use in a room temperature or ordinary temperature and a pressure. But when you are using a nickel, so temperature should be very high. The nickel, when you are using, it is needed always here high temperature. Not only high temperature, we need here high pressure also. High pressure. Hope you understood this reaction. Next, there is one more method is there, that is the reduction of next process, that is seventh process, reduction of alcohols, aldehydes, ketones and carboxylic acids. Okay, now we'll see the one by one reaction. That is the first one. We'll see what is that. Let me take another color. By reduction of alcohol, by reduction of alcohols. So thing is that alcohols contain ROH group, and now this ROH group is heated with the hydrogen iodide, and then we get Ri plus H2O. Thing is that we need here red phosphorus red phosphorus. The temperature is about 150 degrees Celsius. This is how the alcohols are reduced. Okay, this okay reduced. So it is forming here Ri. So I is a good living group as well as the nucleophile. Ri is again reacting with the another molecule of Hi, and we get heat it simply, and we get here RH we get, and along with that we get here I2 molecule. So that is alkane we get here. Alkane. This alkane is formed from the alcohol. That you have to remember first. Okay, next part. In the next part is that take an aldehyde, reduction of aldehyde. So it is a B. Reduction of aldehyde. Okay, and we know that aldehydes can be represented as R, C, double bond O, and here it should be the hydrogen. Okay, and for this we need here 4 molecules of Hi. Okay, then we need here red phosphorus, and the temperature is again same, it's 150 degree Celsius. Obviously we get here RCH2 R, and along with that we get here H2O plus I2. 2I2 will get. Okay, this is one type of reaction. The next reaction I'm going to discuss, that is a Wolff-Kishner reaction. So where we can reduce the aldehydes and ketones, and then I'm going to discuss the Clement reactions. So that should be happen in the next video, students.